this snippet, I would like to give a brief overview of this book, written by a very distinguished uh, physical metallurgist, Professor Cahn. So, what is this book about? The book attempts to portray the different historical stages in the development of material science. It provides an impressionistic map of material science as it existed in 2000. So it's not a very recent book, it's a bit dated, but Professor Cahn was there from the time that material science nucleated from, let's say, 1950s. Um, so he provides the trajectory in the development of material science from that time, 1950s to 2000. So who is Professor Cahn? He's a very distinguished physical metallurgist. This is not the Cahn of the Cahn-Heliot models that we use in material science. So Professor R.W. Cahn has also done very important work in crystal growth, has done excellent work in dislocation, and is very well known for his pedagogy. He has been an editor for many important series in material science, and there is no better source than the book he himself has written. It's like a memoir about his own development in material science. Some of the chapters are technical, so that would provide a good source for understanding his contribution and his development in material science. There is another book which he has written, which is a collection of essays. So he was, I think, an editor for Nature. So these are collection of short essays in material science when he covered a variety of topics for Nature. So this is frontier material science that has been succinctly summarized in a page or two. Each topic is summarized in a page or two. This is a very beautiful book. So if you're interested in material science, his history, and so on, you should take a look at um, uh, the work of Professor R.W. Cahn. So just to give you an idea what this book covers, it talks about emergence of materials, emergence of scientific disciplines. So while his emphasis is on emergence of material science, he also addresses how other related fields nucleated, for example, physical chemistry, chemical engineering, metallurgy, and so on. So these are very important for any person who is working in material science, or in general, someone who is interested in history of science and so on. So we often talk about the material tetrahedron. So Professor Cahn talks about the legs of a tripod in material science. We will elaborate on this topic in future lectures. He also talks about the different branches of material science as it existed in till 2000. Okay, so there are newer branches that have nucleated from 2000, but as of 2000, he talks about the different branches of material science. So he also talks about the practice of material science. And so on, this very nice book, very fine balance between technical aspects as well as history and sociological aspects and so on. So why is this book important? We often aspire to teach science, typically science, engineering, and technology. As we all have limited time, the focus is on just teaching science as core classes or as electives and so on. Okay, so it's important, and the students have limited attention span. So this is what we attempt to teach in classes. However, it's also important to understand and discuss history of science. Okay, so history of science is different from philosophy of science. So why is history of science important? There are infinite number of questions in any field. Okay, so um, but probably there are finite number of consequential questions that needs to be answered at a given point of time. What is to be answered and what can be answered depends, changes from time to time. So, as opposed to philosophy of science, uh, if we look at history of science, probably it gives us an idea of what can be answered in a productive manner. Okay, so the way things become consequential is often nonlinear. There is an availability of resources, tools, and there are many factors which converge, which give rise to consequential answers. So to talk about these things, okay, in a very fairly um, concrete case study manner, history of science helps. So to one cannot master everything, so there is a need to specialize. How much to specialize and how to specialize, these kinds of issues are addressed not in history of science as well as in this book in particular, especially in the context of material science. So, material science emerged from metallurgy, chemical engineering, chemistry, and solid state physics. So, how this happened is discussed in a specific manner in this book. The book is also connected with the history of metallurgy, chemistry, and physics. To a great extent, history of physics and chemistry is timeless. One cannot really write history of chemistry and physics. Okay, so from the time that men and women tried burning wood and tried to use it for something, okay, so there was chemistry and physics. So whenever somebody attempts to write a history of chemistry or physics, it would necessarily be incomplete. But there have been attempts to write history of chemistry and physics. So whenever one attempts to write such a history, it is probably history of modern chemistry and history of modern physics. Okay, so as opposed to that, there are certain other fields which have its own identity as they morphed from some other field. For example, a good uh, point in history of chemical engineering is the publication of this handbook. Okay, so this is probably one of the first textbook of chemical engineering written by G. Davis, who was a practitioner of applied chemistry and chemical engineering later. So this was written in 1901. Okay, so one of the themes that provides identity to chemical engineering is unit operations in chemical engineering. So this book um, brought out that manner, how chemical engineering can be distinguished by its own unit operations. So, as opposed to history of chemistry and physics, a history of chemical engineering is more recent. Compared to history of chemical engineering, history of material science is even more recent. So it's material science even more. It's relatively young. So it probably emerged in 1950s, 60s with its own identity. So this book of Cahn brings about that very well. So as I said, Professor Cahn was there from the time material science nucleated in 50s, 60s, and this book covers material science till about 2000. So, what about the last 20 plus years? Okay, so I always recommend MRS Bulletin to my students because it provides what is at the frontier of material science. It's a in good summary of variety of topics. It's a month. It's published monthly. So, if you want to get an understanding of what is the frontier in material science, MRS Bulletin is a good avenue for understanding. What is the frontier right now. So I think material science is inherently interdisciplinary. So I like a very interesting book in material science. This is the title of the book I'm referring to. It is written by J.E. Gordon, The New Science of Strong Materials, or Why You Don't Fall Through the Floor. Okay, there's an interesting title. I would first request you to read this paragraph. I'm not going to read it out. Let's just pause for a minute and read this paragraph. So this is an excellent paragraph, okay, which succinctly talks about the interdisciplinary aspect of material science. I've highlighted some of the lines in red because they're more important. So first, material science cuts across different length scale and time scale. So if you want to do interdisciplinary work, you should be comfortable in handling molecules, materials, and large macroscopic structure. Okay, so this is one of the very important aspect of material science. It's not molecular science. It's not macromolecular science. Um, so there are many length scales and um, time scales that are very important. There are now many important devices, material centric devices that bring out these features. For example, if you take solid state batteries, there is aspect of course, electrochemical. So there are two things that are covered, but mechanics is a very important aspect of solid state battery. Okay, so to gainfully troubleshoot cutting edge research topics in this field, you should have a very good understanding of chemical forces, electrical forces, and mechanical forces at variety of length and time scale. And I can really quote many other examples. So this is an excellent paragraph, and these J.E. Gordon has written two excellent book that brings out the interdisciplinary nature of material science. So I also think interdisciplinarity is built on disciplines. So unless you are good in some discipline or more than one discipline, you cannot really be interdisciplinary. Okay, so interdisciplinary is also a bridge between two disciplines. So typically, one builds some foundation in a particular discipline at an undergraduate level. Okay, so there are, as I said, there are three main forces: chemical, mechanical, and electrical. So one puts in the foundation, at least one of the forces, mastering one of the forces in the undergraduate years. And as you go to graduate school and so on, you build bridges between disciplines. So this particular thing is important. So you should really become good at one discipline before you start becoming interdisciplinary. That's my opinion, at least. So this is an important theme. So this coming of material science by Cahn brings out the role of interdisciplinary education and research, especially in the context of material science. So what is next? The next, we will move on to chapter 1 of this book, which provides a very rich introduction to variety of topics. So that will be the topic of the next lecture. Thank you.